Okay, so for this one, we are going to be applying different transformations to graph of y equals sine x, and we are going to see how the graph is transformed. Now, this might represent one full cycle. It might not, depending on what the transformations require. Okay, vertical stretch by a factor of 3. That's going to change your amplitude. So that's our A value. I don't love coordinate mapping for this. You can do it, but because we're dealing with fractions, it makes it a little bit more complicated. And we're dealing with radicals, or not radicals, radians. So that makes it a bit awkward. So if a horizontal compression, if the factor is 1/2, that means we're going 1 over our K value, which is 1 over 1/2, which is invert and multiply 2 over 1, which is 2. Okay, so, and I know it says like 1 over K, but like that's of a factor of, that's like what goes there. Okay, so in the equation, we're going to see a 2. Horizontal translation, pi over 6 to the left. To the left would look like plus pi over 6 in the equation. And then a vertical translation down, that's just going to change where your amp line is. That's like my middle. This is sine, so it's going to be middle high, middle low, middle. That's just going to change where your first middle is. So let's go down now. I've screwed up this graph. I didn't give us enough space down here. On a test or an assessment, you will always have a grid, and for the next time that I teach this, I will make sure that this grid is fixed. Hi, Mr. Felber. No, they all left. Yep. Then we're going to go back up here, and we're going to draw our amp line. That's the first thing I'm going to do, because that's where I'm going to base the rest of my graph off of. So my amp line is pink at -1. Then we're going to have an amplitude of 3 up from the amp line and down from the amp line. So 1, 2, 3. This is as high as the graph is going to go. 1, 2, 3. This is as low as the graph is going to go. And we're just kind of making that up because I forgot to give you the extra space. Okay. Now we have to figure out how to make our x-axis. Our x-axis has a translation factor of pi over 6. So if we could make every one of these little boxes represent pi over 6, that would be the best way to graph this. So pi over 6, 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, and 12 pi over 6. Now, that's like you're thinking. I'm going to go back and actually change them into proper fractions now. So 2 pi over 6 is going to become pi over 3 because the 2 divides out. 3 pi over 6 is going to become pi over 2. 4 pi over 6 is going to become 2 pi over 3. Ugh. 5 pi over 6 can't simplify. 6 pi over 6 is just going to become pi because it's 6 divided by 6 is 1. 7 pi over 6 can't simplify. 8 pi over 6 is 4 pi over 3 because we could divide a 2 out of both of those. 9 pi over 6, I could divide a 3 out, 3 pi over 2. 10 pi over 6 would be 5 pi over 3. Because if I divided 2 out of both of those, 5 pi over 3, 5 pi over 3, 11 pi over 6 can't do anything. And then 12 pi over 6, 12 divided by 6 is 2, so this gives us our 2 pi. Whoops daisies, 2 pi. Okay, So a normal sine graph would go middle at 90, high at 180, middle at 3/6. I didn't change that one, did I? That should be 3 pi over 6. Wait a second. That was 5 pi over 6. No, I just couldn't read it. That's why. Wait a second. 7. This is 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6. That's 3 over 2. 3 over 2, 3 over 2. That's the one I want. That's the one I want. And then this would normally be like, actually, it would only go up to 1, sorry. And this would only go down to there, and then it would go back there. So then we stretched it, and we moved it down. So I'm going to jump every one of those points down, and I'm going to stretch it. That one's going to go low, down to that amp line, and then that one would be down on pink. So that's the graph that's been stretched over a normal cycle. Now we have to take this cycle and we have to divide it in two. So everything is getting squashed by a half. So this coordinate right here, instead of being at 2 pi, is going to be there at pi. Instead of being 3 pi over 2, we're going to have to divide that in half. So that's 270. 3 times pi is 180 times 3 divided by 2. That's 270. Half of 27 is 135. What would 135 be here? 135 times pi over 2. Error 1, it's not working. I can't think that fast. Okay, just going to move this one then. We're just moving them, cutting them in half. That's going to be at 45. 45 pi over 3 is 60. Pi over 6 is 30. So 45 is like right in between those two. Then that's going to be the end of it. Where's my second middle one? Half is going to be there. And then halfway between 1, 2, 3 boxes, 1, 2, 3 boxes, I'm at 1.5. 1 box and a half. So now I've taken the graph and I have squashed it in half. Then I have to take it and I have to move it to the left pi over 6. So I'm going to take every point and I'm just going to move it 1 over. There. This one's going to move from the middle of the graph to like the middle of a box. There. This one's going to move over 1. This one's going to move over 1. This one's going to move over 1. So my pi over 2, which was in the middle, is going to move over 1. Then there was 1, 2, 3, and it was right in the middle, is going to move over 1. Then it was right there, down there, it's going to move over 1. So there is the sine curve for one cycle, and now I've got to repeat it. So at 1.5, it'll be at high. At 1.5, it'll be at middle. At 1.5, it'll be at low. At 1.5, it'll be at middle. And it's not going to land right on the 2 pi because we've taken everything and we've shifted it over once. So that's like where it would stop. Okay. I want full marks. I want full marks. I want full marks. Y equals, oh, we didn't even come up with the equation yet. F of x equals amplitude sine. Within the function, I'm putting that k value in a bracket. You don't have to because it's within the function besides sine, but I like doing that. minus 1. So sine f of x equals 3 sine 2x plus pi over 6 minus 1. So first thing I did, put the amp line. Second thing I did, create your range by using your amplitude from your amp line. Third thing I did was graph normal and then apply stretch or compression. And then the fourth thing I did was, or well, I guess the fifth thing I did was apply transformation. Okay.